very good morning, good afternoon, good evening, my dear friends and students. Welcome to this TKM2 NPTEL MOOC course, and this is the 8th class or 8th lecture which we are going to have. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember in the almost till the middle of 7th class, or I won't use the word middle, it's almost till the fag end of the 7th class, we were discussing about general concepts of random variable expected values, then second moment which was something to do with the variance, then the distributions, very not in depth, but in generally the concept for distributions. Then we went into the concept of trying to understand few of the inequalities, Chebyshev's and Markov inequality. Then we went to the concept of an estimation, provided we pick up a sample from a population. What are the two characteristics of unbiasedness and consistency? Then we consider the other three distributions based on normal distribution, which was chi, f and t, and then we went into discussing what are the different estimates. Further on, we ventured and discussed and had a look at interval estimation, what is the concept of level of confidence, then the concept of degrees of freedom came up, and how these three distributions were formed considering the normal distribution and the Bayes distribution. Then we went in the concept of what do you mean by hypothesis testing, what is alpha and beta errors, how we discussed and gave a very nice example in the area of banking, where a loan has to be given and there is a cutoff score. Then we discuss the different type of hypothesis testing rules, and I did mention time and again something to do with the mean or the first moment. You will definitely use the z or the t, and something to do with the variance of the population. You want to find out something, some statements, you will definitely use the chi and f. And obviously, we understood what was x bar, the sample mean, s without the dash, s with the dash, and how the degrees of freedom could reduce by 1 or 2 depending on the example. Like for the f distribution, it was lost 1 1 in both the populations. So, it was m minus 1 n minus 1, and in the case of t distribution, we saw when it was just to do with one population, it was 1 degrees of freedom lost, and then we all further on saw that it was m plus n minus 2, this minus 2 coming because it was being lost 1 from the first population, 1 from the second population. Then we in the last 5 minutes of the 7th lecture, we discussed about what is an experiment, what are the errors, and those were qualitative fields, and slowly we will start off the discussion in this. So, with these words, let us start with full vigor the lecture number 8. Now, the strategies for when you are doing an experiment, because you want to test something and trying to find out what is the best set of input variables such that the white noises or the uncontrollable so called errors can be minimized. So, the general approach to planning and conducting the experiment is called the strategy for experimentation. Consider that someone is trying to lower his or her golf score. This may be either you want to basically try to reduce your blood pressure, it may be that you want to basically increase your input in doing some work, or it may be that you want to jog or walk more in order to reduce your fat or basically be fit. All of this is. So, in this example, considering a game of golf and you want to reduce the score. So, the reduction of the score basically means that you want to be at par or below par such that your score is much better, lower the score better. The type, so you will basically try to find out the type of drive or the club which you use, whether they are oversized, undersized, whether you want to use the club of size 1 or 2 or 3. Then you would basically try to find out what type of ball you will use. So, in India obviously we generally are not very much aware of golf as a game, but there are different type of balls which are there, and if you have seen a golf ball, it is basically not almost, but it is likewise the size of a table tennis ball, but with dimples. So, inward dimples which basically reduces drag and lets the ball have a smooth flight for a long distance. So, these are just the information which I am giving. if somebody is interested to check. So, you will also try to find out what is your walking and the carrying the golf ball or riding the golf cart, what you would try to do, and whether you will try to take a caddy. Caddy is those persons who carry your golf bag with all the clubs. So, we want to have a pull cart or go in a golf cart or have a caddy, and whether the caddy is allowed to give you some advice, change the club and so on and so forth. So, whether you would be basically drinking water or say drinking juice when you are playing the game, whether that is actually allowed, and you want to basically refresh up yourself, because it continues for long and you have to walk for a long time and for quite a distance, because if there are 18 holes, the total distance travel would be in the tune of about 8 to 9 kilometers. So, you would like to play in the morning or the afternoon depending on the weather. You want to play when it is cool or hot, and the type of golf shoes, the spike one, whether they are metal or they are non-metallic, soft, whether you get a good grip on when you are basically trying to take a swing. So, all this basically would be studied in order to understand whether you can reduce your score. So, whether you want to play on a windy day or a calm day. So, windy day basically means there is a lot of wind factor, and the deviation of the ball would happen in such a way that you will be off the target larger than for the case when it is a cool and a calm day. I will not use the word cool day, but calm day means not a windy day. So, best guess would basically you will select an arbitrary set of combinations of these factors, and then try to find out what is the best set of combinations for the external factors, which will help you to reduce your score and basically pull you up with the ranking with your other players, or you want to basically perform better. So, what is generally understood is basically one factor at a time. So, this method consists of selecting a starting point or a baseline from where you will basically try to compare yourself or compare the overall effect of an experiment or an existing condition. For each effect, you take a baseline and then successfully vary each factor over its range with a period for a particular period of time, such that all the combinations would give you some results, which will basically be able to based on which you will be able to judge whether the planning which you are doing for the experimentation or the word experimentation which we are using in the normal sense is really making sense. Some scientific deductions can be made. So, as you change each factor over this range, obviously you will keep the other factors constant at their baseline value whatever you started. Say for example, you think that you will change your timing of the play, you want to basically play in not in the hot, but in the cool weather. So, obviously everything being constant, you will continue practicing for and playing for a long on a cool day, and then try to check how your performance is. Then say for example, you will keep the other factors, one factor changing, other factors being constant, and try to basically compare how your performance is. After all tests are performed in different combinations, a series of graphs or basically analysis are usually constructed showing how the response variable is effective. Response variable is basically the output which you are trying to understand, that whether your score is reduced or whether you have reduced your weight if you are basically jogging. Say for example, jogging and walking, you think, I am not shifting the whole focus of the discussion, I am giving a different example. Say for example, you think that brisk walking in the morning is better, or else you may think that you cannot walk very briskly because in the morning you are a little bit tired. So, you will take some time before you really get in the mood. So, hence you will basically try to or like to switch on to the evening time. Maybe you would like to basically change your path or change your shoes or basically wear a kneecap, or in the winters or the summers you would like to change your timing accordingly, such that you basically give out your maximum amount of energy, because loss of calories would basically burn out your fat. So, you are able to reduce your weight and be much healthier in the general sense. So, when we do that, so you will basically constructing showing how the response variables are affected by varying each factor with all the factors held constant. So, when you do that, it is basically a factorial experimentation which is being done, where factors are varied together instead of one at a time. So, they are varied together in such a way that you are able to understand the collective overall effect on the response. So, in one factor at a time you will basically change one, keep other fixed, and in when you are doing a factorial explanation you will basically do a combination of them. So, what is the important factor which is basically giving the results, if at all you may not be able to judge, but considering the overall different combinations you may make some good guesstimate or estimate such that you can take corrective actions in this direction. So, let us consider an example or in a qualitative sense. In many integrated circuit manufacturers steps, wafers are completely coated with layers of material such as silicon dioxide or a metal. Then the unwanted material is then selectively removed by etching. So, this can be chemical etching and or electrical etching through a mask, thereby. So, basically you have a wafer, you put the very thin layer in microns of a silicon diode, and then you put a mask. Like mask is basically you want to write something on the wall. So, and you have a stencil. It's basically we generally use the right word when we generally use in classes. You want to use a stencil, so the writing is very nice. So, the mask would be put on the wafer which is already coated, as I mentioned, and then you etch out using some chemical process or a micro nano electrical process, so that the circuit is basically made. So, that is how the etching is done. So, unwanted material is then selectively removed by etching through a mask, thereby creating circuit patterns, electrical interconnections and connections are made, and areas in which diffusions or metal depositions are to be made are done. A plasma etching process is widely used for this operation, particularly in small geometry applications. An engineer is basically interested in to investigate the relationship between the RF factor setting and the etch rate for this tool, such that the etching is not too much or not too less. The objective of an experiment like this is to model the relationship between each etch and the power, so as to specify the power setting that will give a desired target rate for each etch, such that if there is more etching or less etching, obviously the circuit basically gets damaged, it is not of no use. So, you have to basically have a particular rate of etching, depending on which the circuit is absolutely perfect. So, there is no so called short circuits and or loops are not there where the current does not flow. So, this is the main aim when you are doing integrated circuits IC manufacturing is being done. So, the engineer is interested in a particular gas, and the gap, say for example, is 0.80 centimeters, and want to test 4 levels of powers, which are 160, 180, 200 and 220. Depending on that, you will want to find out what is the rate of etching. It was decided to test 5 wafers at each level of this power. So, for 1860 we will test 5 of them and find out the average performance. Similarly do for 5 different other IC circuits which has been in the raw stage, like wafer with a coating. Then again for 200 you have another 5, then for 220 you have another 5. So, this is example of a single factor, that means you are keeping everything constant, you are only changing the power to find out the performance. So, these four different wattages into 5 wafers in each, this 20 runs should be made in a random order. So, you need not do 160, 160 all at one go, it can be 160, 200, 220, 160, 180 and in this sequence, any of them. This randomized test sequence is necessary to prevent the effects of unknown nuisances. So, variables which you cannot control, perhaps varying out the control during the experiment is best from contaminating the results. Suppose that we were to run 20 test wafers in the original non-randomized order, that is all 5 160 first, then 180 and so on and so forth. If the etching example exhibits a warm up, so in say for example, when you are doing it 160 one at a time, first go, then 180. So, what you are doing is you are slowly increasing the power. So, that may have an effect undesirable, which should not be there in the experiment, and it would contaminate. I am using the word contamination in a very general sense, that it will contaminate your results. So, the etching tool exhibits a warm up effect such that longer it is on, the lower the observed etch ratings will be. The warm-up effect will potentially contaminate the data and destroy the validity of the experiment based on which you can find some meaningful conclusions. So, this is a set of example. So, 1 to 20 are given for the example. The random numbers sorted out are given, random numbers based on how whichever sequence of etching you are doing, and the power sequence are given. So, if you pay attention to the lastmost column, which is the third column, you will see the powers are changing from 200 to 20, then again 220, 160, then 160, 180. So, this is a random test based on which you are trying to do. So, there is no such biasness which you willingly try to basically force into the system. So taking this information from, as I said, it is basically the Montgomery book. So, etch rate, the table basically discusses the etch rate in angstrom per minute from the plasma etching experiment which you have done. So, you have basically observations which are marked as 1, 2, 3, 4, 5, and the powers are given on the leftmost column, that is starting from 160, 180, 200, 220, and the totals are given from where you find out the averages. So, there are, say for example, for 160 the observations are in, that is angstrom per minute. So, they are, if you consider the row corresponding to 160. So, they are 575, 542, 530, 539, 570. So, the total is 2756, you divide by 5 and you get the averages. So, if you look at the averages which is again given on the rightmost column, they are those corresponding to 551.2, so on and so forth till the last one which is 707.0 are for power values starting from 160 to 220. So, if you basically plot them on a scatter plot on with basically power on the x axis and the etch rate on the y axis. Similarly, you do a comparative box plot with power rate on the x axis and etch rate on the y axis. So, you basically get the box plot, which I will try to highlight. So, these are the box plots for 160, 180, 200 and 220. So, I will just highlight it first here and then go into the next diagram, which is for the power with respect to the etch rate, and you are trying to basically do the scatter diagrams. So, what I want to do is like this. Let me check the color. Yes. So, if you see this middle line, which is the median, 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 and this box. So, the part above, vertically above the median and below the median are the respective quantiles greater than or less than with respect to the median, because the values are increased along the y axis as you go vertically up. So, this gives you the values of with respect to the median and the quantile plots or the competitive box plots. So, if I go to the case where I want to understand, let me use the color with respect to the scatter plots. So, the scatter plots are given for 160, 180, then 200, 220. So, they give me the points, but they do not give me where the median is or the mean is. So, we can find it out and do a study about that. Both graphs indicate that the etch rate increases as power setting increases. There are no strong evidence to suggest that the variability in etch rate around the average depends on the power setting. So, for average obviously would be changing, but considering there is huge amount of fluctuation in and around the mean value with respect to the power, we cannot generally find out. So, on the basis of this simple graphical analysis, we strongly suspect that the power setting affects the etch rate. So, there is no strong evidence to suggest the variability in each etch rate depends on the power setting. On the basis of the simple graphical conclusion, we strongly suspect that the power settings affects the etch rate, and high power settings results in increased etch rate. So, obviously, I am not talking about the variability, it is the average value which is changing. So, average values are the median value I said. So, obviously, there would be another horizontal line would be the mean value. So, obviously, that would change depending on the power setting which is there, which I am putting for this example. Suppose that we wish to be more objective in analysis of this data. Specifically, suppose that we wish to test for differences between the mean etch rate at all levels. So, all these levels are 4 levels which I am considering for 160, 180, 200, 220. Thus, we are interested in testing the equality of all the 4 means. It might seem that this problem could be solved by performing a simple t-test for all the 6 possible pairs of means. However, this is it is not the best solution to the problem. So, t-test is basically, remember, now things would be very clear why we did discuss and spend a decent amount of time, about 7 lectures, leave aside the 5 minutes at the end of the 7th lecture to discuss about different type of concept of hypothesis testing and so on and so forth. Hypothesis testing obviously was in the later part, but before that we just build up the theory for probability distribution, then estimation problem, point estimation, interval estimation. First of all, performing all 6 pairwise t-test is inefficient, so it will take a lot of effort. So, in that case, what should be the answer? Second, conducting all these pairwise comparison inflates the type 1 error, because you are adding up and you are trying to basically compare them. So, obviously, it will be on a additive mode. Also consider that all 4 means are equal. So, if we select alpha as 0.05 level of confidence or 1 minus alpha, whatever it is, the probability of reaching the correct decision on any single comparison would be 1 minus 0.05, which is 95%. However, the probability of reaching the correct conclusion on all 6 comparison is considerably less than 0.95. So, the type 1 error has been inflated, because if you are continuing one after the other, there may be some effect. So, obviously, those concept or interrelationship would be coming up, but which is not being considered. The appropriate procedure. So, now here comes our technical solution. The appropriate procedure for testing the equality of several means is the analysis of variance. So, now what is the general background of analysis of variance? Suppose we have a treatment on different levels of a single factor. So, they can be single, and slowly we will go to the multiple factor that we wish to compare. The observed response from each of the treatment is a random variable, and it is given in the table 3.2. Again, it has been taken from Montgomery, as I did mention for the other 2 figures. So, the treatment levels are given on the first column starting from 1, 2, 3, 4 till A, and the observations for each treatment. So, let us say for example, so for the timing we will consider the number of observations for each treatment are equal. So, obviously, they may change, but for the timing we are considering them to be equal. For treatment for level 1, the corresponding values which we have observed, they are n in number, n is in Nagpur. So, those values are 1 y suffix 1 1, y suffix 1 2 till y suffix 1 n. So, obviously, the first one, if you remember, y, the suffix 1 is basically related to the treatment number, and the second number is basically related to the observation. So, it will be y 1 1, y 1 2 till dot dot till y 1 n. Similarly, if I go to the last row corresponding to the treatment level A, it will be y A is for the treatment, the next number is basically for the reading. So, it is 1, then it 2, 3, 4 till n. So, you have basically the totals are given by, because you will be adding up all the values corresponding to the number. So, it will be y suffix 1 is for the treatment, and then it will be summed up, that is why it is given a dot. So, I will try to highlight this for your own convenience. So, if you see this, there is a dot here, which means, let me change the color, so it will be easier. So, what I am doing is that it is y 1 dot. So, when I am using this dot, it basically means I am summing up all the observation pertaining to n, and in case if I write as y dot, say for example n1, it would mean that I am basically, so the first one which I wrote y 1 dot suffix is basically sum up along the row, and it is y dot n1 is basically for any particular observation we are summing up all the one which are along the column. So, they may be relevant later on, but I just wanted to tell you what is the nomenclature we are trying to follow. So, similarly, so as we do that, we have the totals y1 dot, y2 dot till ya dot. If you sum them up, obviously summation would give you the idea that both would be dots. Dots basically very simply give you the information, they have been summed up both along the rows and on the columns. We find out the averages. Averages nomenclature would also be very scientific based on what we are doing. So, it would be y1 dot with a bar corresponding to the fact that all the sums have been done for the particular reading number and not the experiment number or the treatment level. So, obviously, it can be also put as y bar, then it is dot comma n1 corresponding to the case I am trying to find out the average for a particular reading, but similarly for all the treatment numbers. So, each value represents the jth observation taken under factor level or treatment I. So, there will be in general n observations under the ith treatment, as I did mention it very clearly. So, now what we will try to understand is basically build up the model. So, Yij, which is basically for the treatment number I and the jth observation, it will basically would have some mean value with some error. So, that mean value obviously would be mu suffix I plus epsilon ij, is basically corresponding to the experiment number and the observation number. So, here I is changing from 1 to a and j is basically changing from 1 to n. So, Yij is the ijth observation, mu I is the mean of the ith factor level of treatment, and corresponding epsilon is the random error component that incorporates all the other source of variability in the experiment, including measurement, variability arising from uncontrolled factors, different combinations. It may be the difference between the experiment units which are being used, such as the test element to which the treatments are being applied, the general background noise in the process, such as the variability over time, effects of environmental variables, humidities, they may be related to temperature, pressure, whatever it is. So, the errors have certain assumptions, which is the errors are assumed to have a mean value of 0. So, hence the expected value of if I consider this one, so which I am going to circle now, this average value would be basically mu I as rightly mentioned, and moreover the errors have an expected value as 0. So, obviously, that will not come. The above equation is known as the means model, and the mu value can be written as basically corresponding to an average mean value with some tau I corresponding to, say for example, the h. So, generally what I am considering that if you go back to the experiment of 180, 160, 200, 220, there would be one mean value combined for all of them, and plus and minus would be the value which will come corresponding to the experiment which I am performing, corresponding to the fact that I am changing one of the main factors for the experiment. So, this tau value can be plus and minus depending on how we have set the examples. So, with this I will end this lecture, 8th lecture, and continue discussion more about ANOVA models in the 9th and so on and so forth. And I am sure that things are becoming now right in the right frame of mind, considering that we are slowly trying to basically go into the designer experiments and consider total quality management in the right perspective. Thank you very much for your attention. Have a nice day. Bye.